Hello there, and then welcome to Hub Beyond Numbers, where we learn maths the easy way. In this video, we are looking at translation by a given vector. Now, at the end of it, you'll be able to understand what translation is in geometry, be able to apply a given vector to move points and then shapes. And then you'll be able to identify the image of a figure after translation. So let's quickly look into it without much I say. So let's start by defining or explaining what translation is. When we say translation, it is a rigid motion. Remember in our introduction video, we spoke of what rigid motion is. We said that for rigid motion, it's only the position, the size doesn't change. Okay. So a translation is a rigid motion that moves every point, every point. Take note of this word over here, every point. It moves every point of the shape in the same direction. So every point of the shape, the same direction, the same distance. What does this mean? So let's look at this compound shape we have over here. All of this whole shape. If I'm able to move this, right, I move it in any direction. You see, I'm moving the whole thing. So we'll say I am translating it, right, in any direction. I am translating it. But if I'm not able to move the whole thing, and I rather take a portion of it. So let's say I take a portion of it and then I move. That is not translation. I'm rather destroying it. I would even say it's distortion. You see. So for translation, what does it do? You are moving the whole thing, right? The whole thing in the same direction. That is translation. Okay. Now we are saying it's a rigid motion, as I said earlier on, because it does not change the size. Neither does it change the shape. It only changes its position. So when we change the position, we are undergoing what? A rigid motion. So with the basic understanding of translation established, let's look at how we translate vectors. When it comes to translation of vectors, we have something we call a translation vector. Now this translation vector is written as A, B, so vector, something like this, you see. And the A here tells you how many, the number of units you should move horizontally. It just works on the x-axis. So it tells you how many units you should move horizontally. Then the B, on the other hand, tells you how many units you should move vertically, that is up or down, right? So the A tells you how many units you should move horizontally. So if it is a positive A, then you are moving to the left. If it's a positive A, then you are moving to the right, the number of times. If it is a negative, then you are moving to the left a number of times. You see. Then for the B, if it is positive, then you are moving upwards. If it is negative, then you are moving downwards. So let's say we have a vector with coordinates x, y, and we want to translate that vector. So we want to translate it. Let me just write it this way. So we have this as our vector, and then we have A, B as our translation vector. Now, if you want to translate this vector by this translation vector, then all we do is you have your x, comma, y, and since you are translating, its new position is going to be the value of x plus the A of the translation vector. So plus our A, and then y plus this, the B. You see, and this becomes your what? Initial position. This becomes the initial position of your vector, whilst this becomes your final your final position of the vector. All this wouldn't really make sense unless we solve some examples. So let's solve some examples to see what this is about. So for this first question here, it says we should translate the point A, which has coordinates 2, 3, by this vector over here. We would solve it, and afterwards we would go to the graph sheet to look at how it is done on the graph sheet as well. So we said earlier on that if you have a vector, so this time around is A. So A plus the translation vector v should give you your translated vector. Then our A over here was 2, 3. So plus our translation vector, which is 4, negative 2, right? So that is going to give us, we add the x component and also add what? The y component. It means for the 2, we are moving it by what? 4. You see, that is this x component by what? This here. Then the y component, we add it also to what we have here. So that we have 2 plus 4. Then for the y component, we have 3, then plus a negative 2. You see. So evaluating, it simply means that our a prime is going to be 2 plus 4, which is 6. And then 3 minus the negative 2, which gives us a 1. Hence, this here is our translated vector, as simple as it is. So if you have a pre-knowledge of addition or the arithmetics of vectors, then this isn't going to be a problem because you are always going to add your vector to your translation vector, and that is it. So let's look at how we do this on the graph sheet. So this here is my graph sheet, and I would have to locate A, the point A. We know A was 4, it was 2, 3. So per my scale, I have my 2 and then 3, 2, 3 located over here. So our 2, 3 is going to be here, and that is for our A. Now, per our calculation, we had the translated vector, that is after applying the translation to it, to be 6, 1. So 6, 1, 6, negative 1, so yeah, 6, 1. So we had it to be 6, 1. So 6, 1, I have it over here, right? That was our translated vector, 6, 1. Now let's see what has happened over here. So if this here is the vector we wanted to translate, all right? So this over here. And the translation vector was, if you remember, it was 4, negative 2. So what that means is we should move to the right 4 times. So I'm doing the movement here. Let me zoom that so that you see what I'm doing. So if we move to the right 4 times, that is per our scale. You see, per our scale. So 1, 2, 3, 4. That is we moving 4 times. And then it says negative 2. When I said negative 2, over there means we are going to move downwards twice. So 1, 2, and that is it. You see. So if you want to calculate and then get your resultant or your translated vector, that is fine. It's solely up to you. But if you want to solve it too, it is also fine, and they will all give you your desired answer. Now, in view of that, let's take a shape or a plane figure and let it undergo a translation so that we have a feel of how, apart from points, we can also apply translation. Now, look at this question here. It says we have to translate the triangle PQR by a vector negative 3, 2, where our P, this is the coordinate of P, Q, and then R. Now, how do we go about it? So as I said earlier on, we are going to translate each and every point. And we know that starting with the P, we know our translation vector to be negative 3, 2, right? So if we add P to our translation vector, we are going to get the P prime, or P, yeah, P prime. So coordinate of P is 1, 1. Then we are adding it to that of the translation vector, which is -3, 2. We are going to get a 1 minus 3 because, okay, so let me just say 1 plus -3 and then a 1 plus 2. So it simply means our P prime is going to give us what? 1 plus -3 gives us a -2, and then 1 plus 2 gives us a 3. And we would have to do the same thing for Q and then R as well. So for Q, we are going to say Q plus this vector will give us Q prime. And looking at the coordinate of Q, we had 3, 1, then plus our translation vector, which is -3, 2, should then be equal to, not plus, they should be equal to 3 plus -3, then 1 plus 2. Hence, our KO1 is going to be 3 plus -3. That is going to give us a 0. Then 1 plus 2 gives us 3. All right. Then for the last one, for R, so we have R plus this vector would give us what? The translation vector will give us R1. And coordinate of R was 2, 3. So plus the translation vector, which is -3, 2. I don't know why I keep writing plus. So it's equal to, we have 2 plus -3 and then 3 plus 2. Hence our R prime gives us 2 plus -3 gives us a -1. Then our 3 plus 2 would give us a 5. So these here are the coordinates we will have to plot. You can take note of them and then write them down. Let's go to our graph sheet and then apply them there. So here we have our graph sheet and we would have to draw our triangle, right? Before we draw the triangle, we would have to locate our points. P was 1, 1. So 1, 1. This is where we have our 1, 1 for P. And then that of Q was 3, 1. 3, 1 would be here. Let me just zoom that so that you can see it clearly. Okay. So that is P here, that is Q here, and then our R, which was 2, 3. So 2 on X, we have our 2, and then on Y, we have our 3. This is it over here. So let me just write the coordinates beside them. After which, we then join the lines. We'll have to what? Join these lines. So I'll join P to R, and then R to Q, then Q to R. You do this with a ruler to form your triangle. We now plot the points as well. The point of the translation, you see, and we remember what our P, the translated points were. Let me go back there so that you see them once again. So these were the translated points, that of P prime, that of your Q prime, and then that of your R prime. So let's go back and then do this plotting. So starting from our P prime, its coordinate was, the first one, the P prime was -2, 3. So we come to -2, -2, and then 3. We have that coordinate here. Then for Q prime, it was 0, 3. So 0, 3, 0, 3. This is your 0, 3 over here. And then that of R prime was -1, 5. So -1, then we have the 5 over here. You see, so we can join these lines to form our triangle, and you have to use a ruler for that. Let me write the coordinates as well. So this is what we have here very nicely, and that is just it. You see, so this is how we perform our translation. Now let me do an illustration here so you see what has really happened. So I'm selecting this first triangle here, right? This is it over here. And our translation vector, if you remember, was -3, 2. And we said translation is moving the whole thing the same distance. You get it? So -3, 2. It simply means for -3, we should move to the left 3 times. So that is 1, 2, and then 3. You see, that is the -3 aspect. Then the 2 says we should move upwards twice. 1, 2. You see how the thing has been translated? You get it? So this is what translation is all about. I do hope you have understood, especially how to use the formula to solve it. It's all about adding your vectors and then getting your resultant vector, which is your translated vector. I'll write out some exercise so you try. The video has been long, and then I wouldn't want it to be too long. If not, I would have solved more examples. So here are 3 questions you can try on your own just to test your understanding. The first one, you are just to translate some points. You see, we have some points you are supposed to translate. Then this one here is a parallelogram. So you would have to plot them and then draw your parallelogram, after which you translate them by this vector over here. Then the very last one, you have a triangle. So you plot these triangles with x, y, and z. And then you translate them with this vector 5, -1. I do hope this video was helpful, and if there's anything, you can always let me know at the comment section. This is How Beyond Numbers, where we learn maths the easy way. See you in the next video where we'll look at rotation. Stay safe, and then bye.